All right, reference angles. Now, for many people, this can be a little bit confusing, but I'm hoping to make this clear for you. Reference angles, once you find where the angle is, it's the distance from that point to the nearest x-axis. So I've drawn them out here and given you what theta would be. But what I want to do is this would be theta, this would be for degrees, but this would also be pi minus theta if you're in radians. And here this would be theta minus pi, and here this would be 2 pi minus theta. Okay, so those are your 4 quadrants. So let's go ahead and get started with this one in degrees. 465. So I know that I would go around once to 360. And then I would be left here with a 105. Well, 105, that's more than 90. So I'm going to be in this quadrant. So I know that this is going to be quadrant 2. So I need to do 180 minus theta once I get here. So I go minus 360 to get into its final spin. And I get 105. And then I do 180 minus theta. And so I go 180 minus 105. And that will give me 75. Okay, that's my reference angle. How about this one? What if I'm going negative degrees? Now, negative degrees can be harder to think about sometimes. So here, because this is negative, I'm going to go plus 360 so that I go all the way around one time. And that gives me 16 to 16. Still negative. Okay? So then I need to go around again, so I end up in the positive. Or you need to think negatively. So I'm going to go plus 360. One more time. So 360 take away 216. I am going to have 144. Okay, 144. So this angle is going to be over here in quadrant 2 again. So, since we're in quadrant 2, I am going to do 180 minus 144. 180 minus 144, the hundreds cancel, and I am left with 36. That is my reference angle. Okay, what if I had a radian? Okay, so first thing I need to do is start subtracting off these extra 2 pi's. Well, 2 pi, when I have them in fifths, okay, if I have 5 pieces in each pi, that's going to be 10 pi. So if I subtract 10 pi over 5, that gives me 6 pi over 5. So now the next question is, what quadrant is this? Well, we know that here 1 pi is going to be 5, so here's 1 pi. And then I have 1/5 more, and so I'm going to be here in quadrant 3. So I'm going to be in quadrant 3. And in this rule, I need to do theta minus pi. So I need to take away 1 pi. So this is going to be the same as 6 pi over 5 minus 5 pi over 5, which will give me 1 pi over 5. And that's my reference angle. All right, another negative degree. So starting here, I'm going to start by adding 360. Okay, and fortunately, I already have that here. So I know 216 plus 360 is 144. And I already know this is in quadrant 2 because this is nearly the same problem as here. So I'm going to go 180 minus 144, which will give me 36 as my reference angle. All right, so this problem, negative 160, I'm going to go plus 360, and I'm going to get 200. So 200 is more than 180, so I'm in this quadrant 3. So I'm going to say 200 minus 180 will give me 20. That's my reference angle. Okay? And this one is already only one time around because 11 is less than 12, so it's less than 1 pi. So I'm in quadrant 2 here. So I need pi minus 11 twelfths. So pi minus 11 twelfths pi equals, well, this would be 12 twelfths minus 11 twelfths, which would give me 1 12th pi. And then this one, 17 twelfths. Well, 17 twelfths, I know it's less than 2 pi because it's less than 24. So this is 12 and then 24. Less than 24, but more than 12. So I'm going to be in one of these two quadrants. So then I look at this, and if I took 12 away from here, I'd have 5. So half of 12 is 6. So this would be 6. Sorry. Half of 12. So I'm doing this problem here. 12 goes in here one time, leaving 5. So that's pi, and I come here, and I've got 5 twelfths left. Well, this would be 6 twelfths, so I'm in this quadrant 3. So I am going to do, since I'm in radians now, 17 pi over 12 minus 12 pi over 12. Because this is just pi, I am following this rule here. Gives me 5 pi over 12. And that is my reference angle.